Hello everyone. In this question, we are asked to find the value of a sum of r from 1 to 10 of r upon 1 minus 3r square plus r to the power 4. Okay, so if we start the question, we are given the sum of r from 1 to 10 of r upon 1 minus 3r square plus r to the power 4. Okay, so our target should be to make this into a series of differences, okay, using the method of difference using some partial fraction. This should be our target. So in order to do that, let us try to factorize this denominator. Okay, so the denominator summation is from r goes from 1 to 10. If we look carefully, this term is r square whole square, this is 1 whole square, we are given 3r square. Okay, we need minus 2r square for this to be r square minus 1 whole square, right? So if we try to write it like r to the power 4 minus 2r square plus 1, we are left with 1 minus r square, right? So we can write it separately, minus r square upon r. Okay, so now if we look carefully, this is r square minus 1 whole square minus r square. So this becomes a square minus b square. So we can write it as a plus b into a minus b. Okay, so now this becomes r goes from 1 to 10 r upon r square minus 1 whole square minus r square. Okay, so the denominator now can be written as r square minus 1 minus r into r square minus 1 plus r. Okay, now we have to write this numerator as a difference between these two terms. Okay, this is the method of difference or partial fraction. So among these two, usually assuming r is positive, right? So this is the larger number, right? Since this is r square plus r minus 1 and this is r square minus r minus 1. So this is larger, right? This is larger and this is smaller, right? So if we try to write it as the difference between this and this in the numerator, this will become r square minus 1 plus r minus r square minus 1 minus r. Okay, so if we open the bracket, we see we get r square minus 1 will get cancelled out and we are left with 2r, right? But we only have a single r here, so we have to divide this sum by 2. Okay, so now this becomes like this. Okay, so now on separating them, half is there, r equal to 1 to 10. On separating these fractions, we get 1 upon r square minus r minus 1 minus 1 upon r square plus r minus 1, right? Okay, so now if we try to put the values of r equal to 1, r equal to 2 and so on, okay, we see what we get. So in the first term for r equal to 1, this becomes 1 square minus 1 minus 1. Okay, so this becomes 1 upon minus 1. So first term is minus 1. Then this becomes, if we put r equal to 1 here, this 1 square plus 1 is 2, 2 minus 1 is 1. So this becomes 1 again. Okay, this is for r equal to 1. Then we try for r equal to 2. For r equal to 2, this term will become 2 square, which is 4, minus 2 minus 1. So this is 1 upon 1, this becomes 1. Then this becomes, on putting 2, this is r square 4 plus 2 minus 1 is 5. So this becomes 1 upon 5. Okay, similarly, we see for r equal to 3. For r equal to 3, this becomes 3 square 9 minus 3 6 minus 1, so 1 upon 5. Okay, so if we look at the pattern, the second term for r equal to 1 cancels the first term for r equal to 2. Similarly, the second term for r equal to 2 cancels the first term for r equal to 3, right? This term is left out. So if we go putting all these values, we see these values will cancel each other. Okay, I'm not calculating this expression, but you can try this also out. Okay, So we see this value and this will cancel each other. This 1 by 5 and 1 by 5 will cancel each other. And ultimately, the term that will be left out will be the last term here for r equal to 10. This value will get cancelled out also here. Okay. So the last term that will be left out will be this value for r equal to 10. So this will become 10 square 100 plus 10 110 minus 1. So this is 1 minus 109. Okay. This value will also get cancelled somewhere here. Okay. And this value will also get cancelled somewhere here. So you can try to calculate all these values, but these are all getting cancelled out. Okay. So the only two values that are left out will be this first term and this absolute last term. So this becomes minus 1 upon 109. So this now becomes minus 110 upon 109. So this gets 110 by 2 is 55. Okay, so minus 55 upon 109. This is the required final value of this sum. Okay. Usually in these sums, you need to just calculate this partial fraction out properly. Okay, you need to factorize this denominator and do the partial fraction for the method of difference. And the rest is easy. When you can do this correctly, these terms, consecutive terms, usually cancel each other out. Okay, so this is the final answer. Okay, this was an easy sum. Thank you.